So very quickly we have this thing that I'll just do a couple of questions with unequal electron gain and loss, right? So let's have aluminium with oxygen. I want to make aluminium is a metal, oxygen is a non-metal. Aluminium would lose electrons and oxygen would gain electrons, right? So aluminium plus oxygen. So let's do this one. So aluminium is 13 electrons and oxygen is 8 electrons. Aluminium is the one, it's 283. So it's going to lose these 3 electrons. And you've got oxygen on the other side, that's 2 and 6. So that is the one that's going to gain 2 electrons. Okay, so metal, non-metal, right? This loses 3 electrons, and that is the one that's going to gain exactly 2 electrons. So I'm going to draw aluminium first. So I'm going to draw 3 shells. So that's 2 electrons, 8. And then you have 3 electrons in the last shell. 2, 8, and 3. That's aluminium. And you've got oxygen. Okay, so oxygen will be so oxygen will have 2 shells. Let's keep it like that. So it's going to have that's the first shell. 2 and 6, right? And that's kind of your second shell. So 2 electrons and 6 electrons. As I told you that I told you this. The shortcut was don't worry about who's losing electrons, who's gaining how many electrons. Aluminium wants to lose. The metal would always lose all its outer electrons. It's going to lose all 3 of them. Okay, so if I draw this over here. So the metal would lose the entire outer shell electrons. All of them are gone, right? 3 electrons lost. The charge it's going to get when it loses those 3 electrons will be +3. It's going to be +3. And oxygen needs 2 electrons. So oxygen will gain just 2 electrons. And if it gains those 2 electrons, the charge that the oxygen will get is going to be, if it gains 2 electrons, it's going to be -2. Okay? So that is what the ions would look like. One loses 3 electrons, the other one gains 2 electrons. And the shortcut I told you was, okay, if you see a -2 charge over here, that means you're going to go to the other one and multiply it by 2. Okay, so whatever number you see on the other side, this one, if it has a -2 charge, go and multiply the other one by 2. If you see a +3 charge over here, reach this other side and multiply it by 3. Okay, so there's going to be 3 oxygens and there would be 2 aluminiums. Why? Because why? The reason is simple. And the reason is pretty straightforward, that if aluminium loses 3 electrons, if you have 2 of them, then there would be 6 electrons lost. Oxygen gains only 2 electrons. If you have 3 of them, that's 6 electrons gained. So the number of electrons gained and lost would become equal. Okay? Is this clear to everyone?
Yes, sir.
So remember, this is what's going to happen. And that's the shortcut. You don't have to calculate this. All you have to do is make one of them the ion, the other one. Make them the ions, and we'll do just one more example similar to this. Let's have got sodium and nitrogen, right? So let's say we've got sodium, and I want to make the ionic dot and cross diagram. Sodium is 11 and nitrogen is 7. One of them is a metal, the other one is a non-metal. Sodium is 11 electrons, that's 2, 8, and 1. And nitrogen over here is going to be 2 and 5. Okay, so you got 2 and 5, you got 2, 8, 1. Quickly draw the so sodium's got 3 shells. Achha, how many electrons would sodium lose?
1, sir.
Okay, so it's going to lose that 1 electron, right? And how many electrons will be gained by nitrogen over here? Kya hoga? It's right now it's nitrogen is 2 and 5. So how many electrons would be gained by nitrogen over here? I say, like, how many does it need to complete its outer shell?
3, sir.
Okay, so it needs 3, right? So that's all you're going to do. Forget who's gaining electrons, how many electrons, or who's losing how many electrons and who's gaining. Iska outer shell, that's gone. If it's gone, it's going to be +1. Okay, they're both going to complete the outer shell. This other one is going to gain electrons, 3 of them, right? So if it gains 3 electrons, it's going to be -3. So this is -3. Next step is, if this is +1, multiply this by 1, which means that there's going to be just one nitrogen. And if this is -3, forget the plus and minus. If this is -3, multiply this by 3. So there's going to be 3 sodiums, and they're going to be, and there's going to be 1 nitrogen only. So that is what the dot and cross diagram of sodium nitride would look like. Okay? So just simple, make them into ions with complete shells. This by losing the outer shell electrons, this by gaining electrons, and just do crisscross. That's it. Okay? Do this every time. So next thing, we're moving towards simple covalent structures. Okay, so this one, simple covalent molecules. That's not giant, but simple. So now we've got simple covalent molecules. First thing is that it happens, this covalent bonding happens only in non-metals. Achha, wahan pe, why did you have ionic bonding? Because you had a metal and a non-metal. The metal was the one that wanted to lose electrons. The non-metal was the one that wanted to gain electrons, right? But what do non-metals like to do? Do they like to gain electrons, lose electrons? What do they want to do?
Gain electron.
Okay, so agar ions ki baat kare, they always like to gain electrons, right? So they always like to gain electrons. Now, here's a problem that's going to happen because no one is willing to lose electrons. Like if I take the simplest molecule, I've got a hydrogen atom. It's got 1 proton in its nucleus. So there's a hydrogen proton and there's 1 electron in its outer shell. And then there's another hydrogen atom. And that hydrogen atom also has exactly 1 electron. So it's a non-metal, right? It likes to gain electrons. So how many electrons would it need? First shell mein kitne aate hain? How many electrons would it need? Like this hydrogen atom, how many electrons does it need?
Sir, it needs one wall to complete its shell.
Because the first shell only has 2 electrons. So we know that the hydrogen atom would try to gain electrons. And there's another hydrogen atom that would also try to gain electrons. What will eventually happen is they're both trying to gain each other's electrons. I mean, this hydrogen atom over here will try to gain electrons from that hydrogen atom, right? But no one is willing to lose electrons. Ye wala jo hydrogen atom hai, this one over here, would see the other atom's electrons and it will try to gain electrons. Okay? So think of it as two people standing next to each other. And they're both trying to steal each other's electrons. So the end result would be, okay, one of them is trying to pull electrons, but one of them is trying to gain, like, I mean, remember, both of them are trying to gain electrons. So it's like a tug of war that's happening. Ek right side pe electrons gain karne ki koshish kar raha hai, the other one is trying to pull electrons towards itself, right? The other one is trying to pull electrons to the left side. So where do the two electrons end up? They get stuck in the middle. It's a tug of war. If there are two people fighting over something, one of them is pulling it on to the right, it's trying to gain that, the other one is trying to pull it to the left. The thing will remain right in the middle. It's not going to go anywhere. So that's called sharing of electrons. This is what's going to happen, that the two hydrogen atoms are basically fighting over electrons, and the electrons are now stuck in the middle. One of them is trying to pull electrons to this side, the other one is trying to pull electrons to the left side. The electrons then kind of get stuck in the middle. Again, that's what is known as a covalent bond. And it only happens when you just have non-metals. Because if you had a metal somewhere, the metal to electron lose kar jata, it would form ions. But a non-metal is not willing to lose electrons. It's always trying to gain electrons. So the electrons are stuck exactly in the middle, and that's known as a single covalent bond. And you've got, so that's known as a single covalent bond. And you've got, hydrogen has just one proton. So there's one proton in the nucleus over here. Let me, better to draw a nucleus. So there's exactly.
All right. Are you okay?
So, yeah.
I said there's exactly one proton. Firstly, we're doing covalent bonding. Your mic is on. If you can mute it. You can use the space bar to actually unmute yourself. I said we're doing simple. We just started simple covalent bonding. Just a second. If you have questions, you can ask questions after class. Now, and I'll share recordings of the previous lecture as well. I said this one. So that's known as a single covalent bond, and hopefully everyone knows this. If they're going to ask you, why is there a force of attraction? The reason there's a force of attraction is because the shared electrons are being attracted by the two nuclei. I mean, there's the shared electrons in the middle, right in the middle. The shared electrons have negative charge. So there's a lot of negative charge right in the middle. So you can think of it this way, that there's a positive nucleus on one side, and there's a positive nucleus on the other side, and there are electrons, negative electrons right in the middle. So a covalent bond is an electrostatic force of attraction, just like an ionic bond. So it's an electrostatic force of attraction between the shared electrons and the two positive nuclei. Shared negative electrons and the two positive nucleuses, or nuclei, that's the plural. So this nucleus getting attracted to the shared electrons, this nucleus positive is also getting attracted to the two electrons. Okay? So that's what a single covalent bond is. Is that clear?
Yes, sir. Yes, sir.
Yes, sir.
Achha, so I'll just repeat. if one of them had been a metal, it would just have lost electrons. The other one would have gained electrons. But if you have two non-metals, both would try to gain electrons, and both would be unsuccessful at gaining electrons. They'll just be fighting over electrons, and the electrons would be stuck in the middle. So I'll make a double covalent bond now. Let's say I've got two oxygen atoms, right? Okay, let's do another one. I got two oxygen atoms. So here's I said now in covalent bonding, they never ask you to draw the whole atom. Oxygen is in group 6, so I automatically know I don't have to draw all the shells. So mostly in covalent bonding, you don't draw all the shells. So oxygen is in group 6. So how many electrons are in the valence shell?
6.
Okay, you got 6 electrons. So same thing is going to happen over here. So as remember, you don't have to draw the whole shell, all of the shells, just the outer shell, that's enough. So you got oxygen over here. You got this other oxygen over here. I said, now, how many electrons does oxygen need? A non-metal always likes to gain electrons. How many does it need?
2.
It needs 2. So Dubara, they will start fighting with each other. This oxygen will try to gain the 2 electrons from, so it sees the 2 electrons from the other atom, it will try to gain those 2 electrons. The other oxygen will kind of do the same exact thing, that it sees these 2 electrons and it will try to gain, so they're both trying to gain 2 electrons from each other. Okay. As I so they're both trying to gain electrons from each other, and what will happen now is that the 4 electrons will get stuck right in the middle. Okay, because one of them is trying to pull them towards the right, the other one is trying to pull them towards the left. They're both fighting over these electrons, right? And the 4 electrons would get stuck right in the middle. So I'm just going to redraw this, and they would start overlapping in the middle. I mean, the overlapping kind of shows that that the electrons are now stuck. Okay, so I'm going to remove this. And so that's a way of showing that the 4 electrons are stuck exactly in the middle. This nucleus getting attracted to the shared electrons, this nucleus also getting attracted to the shared electrons. Okay. So is this clear, this one? I'll explain how the shortcut is, but is that clear?
Yes, sir.
So let's do just one more. I mean, this one was where both atoms were sharing electrons equally, right? What if atoms are not sharing electrons equally? Like I've got carbon. Carbon is a non-metal, and it's in group 4. That means it's got 4 electrons only, right? I said it's got 4 electrons only. So carbon is in group 4. How many electrons does it need?
Four.
Okay, so it needs 4. But what if you have a hydrogen over here? Now the hydrogen has only 1 electron. So how many hydrogens would you need? Because carbon needs 4 electrons. Hydrogen, it can pull an electron from hydrogen. And there's going to be overlapping that will happen over here. Hydrogen will not lose the electron. So the whole hydrogen atom will come along with it. So you would need 4 hydrogens because carbon needs a total of 4 electrons, right? So here's another hydrogen atom will come in and share electrons with the carbon. Then there's going to be another hydrogen because hydrogen can only give 1 electron. So here's another hydrogen atom coming in. And finally, you got another hydrogen atom coming in. So in this way, the CH4 molecule is complete. Carbon got its 4 electrons, but the problem now was carbon was not able to get those 4 electrons from a single hydrogen atom. It had to attract 4 hydrogen atoms. Okay? So it had to do this. Is this clear, this one?
Yes, sir. Yes, sir.
Okay. And so now covalent bonding can be kind of complicated. One thing that you would notice is carbon needed 4 electrons. So how many electrons did it share? It shared 4 of them, right? I mean, four of its electrons. One green over here, one green over here, one over here, one over here. So carbon needed 4 electrons. Similarly, these other atoms, oxygen needed how many electrons? It needed 2 electrons to complete its outer shell. So how many electrons did it end up sharing? 2 of them. Like one oxygen atom ended up sharing 2 electrons. So the point is that an atom will share the same number of electrons that it needs to complete its outer shell. If I take fluorine as an example, fluorine is group 7. So the fluorine atom, so I got 2 fluorine atoms. The fluorine is group 7. That means it's got 7 electrons already. So it needs just 1 electron. So it will share just 1 electron. Okay, I've got this other fluorine. So both of them, they need 1 electron. They both will attract each other's 1 electron. So if they need 1 electron, they will share 1 electron. So end result is they both end up sharing 1 electron in the middle each. So we can come up with a rule over here, which is an atom would share the same number of electrons that it needs. So an atom would share the same number of electrons which it needs to complete its outer shell. Are you rule clear, or why is this clear, Shoaib? Abdullah, is this clear? Ayan?
Yes, sir.
Yes, sir.
So an atom needs, if it's group 5, so I can make this rule that if something is in group 7, it will always share 1 electron because it always needs 1 electron, right? So if something is in group 7, it already has 7 electrons. So shares only. So it's going to share 1 electron, which means it's going to make 1 bond. And we can apply this to group 6. It needs, it already has 6 electrons, so it's going to share 2 electrons because it needs 2 electrons. And it's going to make 2 bonds, covalent bonds. Then you have group 5. They have 5 electrons, they need 3 electrons. So they're going to share a total of 3 electrons, and they're going to form 3 bonds. And then finally, you've got group 4. They need 4 electrons. So they're going to share 4 electrons, and they're going to make 4 bonds. And we can write, now hydrogen is not in any group, so we can write it as an exception. So hydrogen only has 1 electron, so it shares just 1 electron because it only has 1 electron. And therefore, it only makes exactly 1 bond. So those are our rules now. And there's another problem with dot and cross diagrams that it kind of gets confusing. Like how many hydrogen atoms do I draw? How many carbon atoms do I draw? And so on. So one way to do this is before drawing the dot and cross diagram, draw stick diagrams, which are known as structural formulas. So you should draw structural formulas. One second. So you should learn how to draw structural formulas first. Because jumping onto dot and cross diagrams, I mean, it would be easy for small molecules, but bigger molecules, it kind of gets difficult. So here's what a structural formula is. I'm going to draw, let's try the first one. You know, listen to this carefully. Because the thing is, remember, hold on a second. So the thing is, okay, you're going to create a lot of mess if you draw circles and then you have to redraw them. It creates a lot of mess. So I'm going to try and do the structural formula of CH4. So it's a bond between carbon and, I mean, it's a covalent molecule that's formed between carbon and hydrogen, right? So based on the table, carbon is in group 5. So how many bonds will it make? Group 5. How many bonds will it make? Sorry, group 4.
3 bonds.
No, group 4,
Yes,
sorry.
sir.
Oh,
4 bonds.
4 bonds.
Okay, so it's going to make 4 bonds. And hydrogen, remember, makes only 1 bond, right? Okay, so based on this table over here, I was able to figure this out. Carbon is in group 4. Okay, makes 4 bonds. So what I'm going to do is, I'm going to use these dashes or sticks. I know, okay, I've got a carbon and a hydrogen atom, right? So carbon is supposed to make 4 bonds. Hydrogen is only going to make 1 bond. So hydrogen ki bonding is complete, right? It's complete. I mean, hydrogen is done. Hydrogen wanted to make how many bonds? 1 bond, right? So your hydrogen over here is making 1 bond. So that means don't touch it again. It's done. It's complete. Don't mess this up. It's supposed to make 1 bond. And so how many more bonds does carbon need to form? Because carbon's 4 bonds are not complete. So how many more bonds?
3 more.
It's supposed to make 3 more bonds. Now, I can't add an extra bond over here. Why? Because the reason is hydrogen only makes 1 bond, right? So that will mess that up. So I can't increase the number of bonds over here. So there has to be another hydrogen. And carbon will make another bond with that hydrogen. So hydrogen ke bonds, again, they're complete, right? It wanted to make just 1 bond. Carbon still is not complete. It's supposed to make 4 bonds. So there's going to be another hydrogen, right? And so that hydrogen is also fine. It's making 1 bond. And carbon is still not complete. It's supposed to make 4 bonds. So I will add another hydrogen. Its 1 bond is complete. Now this carbon is done. It's making 4 bonds. So this is what the structural formula of a molecule between carbon and hydrogen would look like. Is that clear?
Yes, sir.
So start with this. Drawing the dot and cross diagram after this is easy. Like now you know which circle to place where. Like you know the carbon is in the middle, right? The hydrogens, there are 4 of them, they're on the side. Okay, so now you're not going to mess up the dot and cross diagram at least. Okay, so think of the structural formula as your rough work. So draw 4 of the hydrogen atoms. I say everywhere there's a single bond, right? This single bond means 1 electron being shared each. So you got a single bond over here, a single bond over here, a single bond over here, and a single bond over here as well. So that's the carbon in the middle. That's it. One thing that you should ensure at the end is that each one should have complete outer shells. This one has 8 electrons. This one has 2 electrons. Hydrogen ka first shell tha. So it's going to have 2 electrons, right? So now the structure is complete. So remember, do this first because that will get messed up. You'll redo this, then you don't have a lot of space in the paper to do a lot of work, rough work. So it's a lot easier to come up with the structural formula first. So we're gonna learn, because isko dekh ke na, this one, making this one is easy. Like which atom to put where. Acha, ye part clear? Is this clear? This one?
Yes, sir.
So we'll just practice structural formulas a bit. So let's say I have a molecule of, now I'm going to make it slightly more difficult. So let's say I've got a molecule of HCN. And they've given us the formula that it's, well, let's try, let's try HCN. And they're asking you to draw the dot and cross diagram of this. Now, the first thing is you have to figure out who makes how many bonds. So hydrogen is one bond, right? So it will make only one bond. Achha, carbon on the other hand, group 4, kitne banayega? It's group 4.
4 bonds, sir.
Okay, so that one is going to make 4 bonds. And nitrogen is group 5. So how many bonds? Group 5. How many bonds?
5 bonds.
No, group 5 is. Group 5 is going to make 3 bonds. 5 means it already has 5 electrons. It just needs 3 electrons. So it's going to make 3 bonds. Is that clear?
Yes, sir.
So that's going to make 3 bonds. Yoga. I'm going to draw, before drawing the dot and cross diagram, I'm going to draw the structural formula. So I know that H makes only 1 bond. So there's only 1 bond coming out of H. That's it. Done. H is done. Who is it going to make this bond with? The next thing is you can add carbon, right? So it can only make 1 bond with carbon. So carbon makes 4 bonds. Who will carbon make the rest of the bonds with? There's no other option. So the molecule is given to you. The formula is given to you. There's only 1 hydrogen, there's 1 carbon, and there's 1 nitrogen. Now, who will carbon make the rest of the 3 bonds with? The rest of the 3 bonds are going to be made with. So they're going to be made with nitrogen over here. Okay, because there is, one second. I said the rest of the 3 bonds will be made with nitrogen because there's no other option. And nitrogen wants to make 3 bonds. So now the structural formula is complete. Carbon wanted to make 4 bonds. So it made 1 bond with the hydrogen. And the rest of the 3 bonds with nitrogen because nitrogen wanted to make 3 bonds and hydrogen over here wanted to make 1 bond. Okay, is this clear, this one?
Yes, sir.
So, drawing the dot and cross diagram would be easy. Like you got carbon in the middle. You got nitrogen on this side. You got hydrogen on this side. You know exactly how many electrons will be shared. This is carbon, this is nitrogen, and this is hydrogen over here. There's a single bond over here. There's a triple bond over here. So that triple bond means so that means 3 pairs of electrons being shared. What is shaded dot in, that's the symbol of nitrogen over here. So that's the covalent bonding over here. One thing at the end, once you're done with this, at the end, make sure that the outer shells are complete. Okay, so carbon has 8 electrons, that's complete. Nitrogen does not have, agar sare count karo na around it, if you count it, it's not having 6 electrons. It only has 6 electrons, it doesn't have 8. So that means that 2 electrons that are left. Now it's 8. These are known as lone pairs. But these are electrons in the outer shell that are not involved in bonding. But the lone pairs pehle bhi the. You had like you had fluorine, right? In fluorine's case, you just had 1 electron being shared. The rest of the electrons were not involved in bonding. So those are your lone pairs, which means they're not involved in bonding. The same happened in oxygen as well. When we did oxygen bonding, 2 electrons were being shared. the rest of the electrons were not doing anything. So those were your lone pairs. So coming back to this, I drew the HCN molecule. I figured out the number of bonds. I was able to draw the structural formula because I knew that carbon makes 4 bonds, hydrogen makes 1 bond, so 1 bond with this, and the rest of the 3 bonds with nitrogen over here. I just copied this structural formula, 3 atoms, hydrogen, carbon, nitrogen, a single bond over here, that's 1 electron shared, triple bond on the other side, that's 6 electrons being shared. And then make sure everyone has a complete outer shell. If it's not, you add the specific number of electrons. Nitrogen had 6 electrons, so I added these extra 2 electrons so that nitrogen has a complete outer shell. TK, is this example clear?
Yes, sir.
So we would have to do a bit more of them. For example, let's say I've got CO2 now. Okay, so the molecule clearly says that there's carbon and 2 oxygens, right? Carbon is group 4, so that means it's going to make how many bonds? It's going to make 4 bonds. Oxygen is group 6, so it's going to make 2 bonds. So you've got carbon over here, you've got oxygen over here. Now oxygen only wants to make 2 bonds. So that's 1, that's 2. That oxygen is done. Oxygen only wanted to make 2 bonds. Carbon's 4 bonds are still not complete. So carbon needs 2 more bonds. So there's going to be the other oxygen, which is going to make 2 more bonds. Now this carbon is, the structural formula is complete. Now carbon is able to make 4 bonds. 2 with this oxygen and 2 with the other oxygen. Okay? Is this clear?
Yes, sir.
What clear hai? Ayan, Abdullah, is this clear?
Yes.
So all I'm going to do now is carbon, oxygen on the 2 sides. Okay, so once I have this, I'm not going to think a lot. I'm just going to copy that, just that. There's a double bond over here, 2 bonds over here. So that's 1 bond. That's another bond. There's a double bond on this side as well. So that's 1 bond. There's the second bond. Okay, the shading, everything is done. Just at the end, make sure that the outer shells are complete. Carbon has, if you look around it, it has 8 electrons. How many more electrons should I draw for oxygen? If you look around oxygen, how many electrons does it have? It's got 4 electrons, right? So it should have 8 electrons. So I should draw 4 more electrons for this. And this oxygen over here as well. If you look at around it, it's got 4 electrons. It should have 8 electrons. So I'm going to draw 4 more electrons around it. And that's my dot and cross diagram for carbon dioxide. Okay, so remember the steps. Draw the structural formula. Figure out who makes how many bonds. Once that is drawn, convert it into a dot and cross diagram. Oxygen, carbon, oxygen, oxygen, carbon, oxygen, double bond. So I added the double bond. And then just make sure that everyone has 8 electrons around them. Okay, clear hai saaron ko?
Yes, sir.
Yes.
Chalo, kal we'll try and do more dot and cross diagrams, because remember, dot and cross diagrams, the molecules can be quite complicated. So what you can at the moment try and do is try doing these 2 questions. You got, let's say you got C2, F6. Try drawing the dot and cross, send it in the group, and try doing this one, N2 and H4. And I mean, these 2 are difficult. I'll have it. Let's have an easy one as well. Let's say you've got What can I add? Just a second. So let's say we've got H2O2 as well. All three are actually difficult ones. I mean, moderate or difficult ones. Hand it in before, like, try it right now if you have time. But by tomorrow, try and draw the structural formula, at least the structural formula. You got 2 carbons, 6 fluorines. How do they fit together? You got 2 nitrogens, 4 hydrogens. You got 2 hydrogens, 2 oxygens. Look at the periodic table and try and figure this out. Okay? So I'll share this in the group as well. चलिए ठीक है, कल फिर बात होती है, ठीक है?
Okay, sir.
Okay, take care.
Okay, sir.
Office, sir.
Office.